Okay, section 1.7, the power of a power. So here we go. Let's just jump right in. Remember, 2 to the 4th times 2 to the 3rd, especially when you see it all expanded out, you're just going to end up basically adding these two powers together to make 2 to the 7th, right? So whenever you have some base to a power times the same base to a power, you add the powers. But this is a different situation. This is something kind of new maybe, or maybe you've seen it before in an earlier class, like back in middle school or something. So what does this mean? You have a base that's being raised to a power, but then you're just like immediately raising all this to another power. So that's why the title is the power of a power, because you're raising something to a power that already has a power. So again, let's kind of see what's going on behind the scenes and kind of what this means. So what does it mean? Let me help you out here to know what to think. What does it mean to raise something to the 3rd power? Something to the 3rd power means that you write it 3 times and you're multiplying them all together. So it'd be 2 to the 4th times 2 to the 4th times 2 to the 4th. That's what raising something to the 3rd power means. And then individually, this purple 2 to the 4th, wouldn't that be 4 factors of 2 just right there, and then another 4 green factors of 2, and then another 4 blue factors of 2? And if you count all these, 2 times 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 2, what is that? 2 to the 12th. 2 to the 12th. Okay, do you pretty much realize what just happened? Maybe you can already start thinking about bypassing all of this expansion and all, the expanding. And what would be like a shortcut to go from here to here, just like that? A few more examples, and maybe you can figure out the trick. If we have 2 to the 8th to the 2nd, it ends up being 2 to the 16th. If we have 2 to the 5th to the 7th, it ends up being 2 to the 35th. 5 to the 10th power to the 3rd power, all of it to the 3rd power, it ends up being 5 to the 30th. And x to the 6th to the 8th ends up being x to the 48th. So what's the trick? What's the shortcut? Well, you probably maybe even see the spoiler here below, or maybe on the back of your paper, I don't know, right now. Right here. Here's something huge. So, I don't know if you want to put another star or circle something. I don't know. This is really, really, really important. At least underline that part, because basically whenever we are raising a power to a power, multiply the powers together. Okay? So here we go. Simplify. Write, looks like there's a typo here. That could be a potential bonus point in class. I wonder if anyone caught me before I realized that. Write your answer in exponential notation. Remember, exponential notation just means having an exponent. So, anyway. So number 1, 2 to the 5th to the 2nd. We're definitely raising something to a power that already has a power. So we multiply the powers together and end up with that. And that's in exponential notation because it's got a base and a power. Number 2, nothing real different here. We're just going to multiply these powers together to get the 21st power. Wow, that's a 1 followed by 21 zeros. Number 3, where this fraction's being raised to the second power, and then all of it's being again raised to the sixth, so power to a power. And once again, this base of 4/5 as a fraction, got to keep those parentheses. It's very, very, very important. And then 2 times 6 is 12. Same kind of thing in number 4. You know, the thing that's being raised to the 4th and then re-raised to the 5th is the entire 3x in parentheses. So make sure, once again, you put 3x in parentheses for that final exponent of 20. Okay? Maybe some different kinds of examples, perhaps. Number 5, you know what I would do first? Is I would do x to the 3rd times x to the 4th. You know, in other words, like, you know, this shouldn't be too of a foreign idea to you. You're going to do what's in parentheses first, I guess, in a way. So now how do we do x to the 3rd times x to the 4th? You should remember from last section that that's where we add the powers together. Okay? And so now we have just strictly a power to a power, and now we do multiplying of the powers. So the final answer after adding the powers to do this and then multiplying the powers to do this part, you get x to the 14th. Number 6, same deal. First thing you want to do is probably do x to the 6th times x to the 2nd by adding the powers to get x to the 8th. And then in order to raise it to the 3rd power, you multiply the powers. Alrighty? Number 7, you should look at this and probably see, you know what, I want to do, just like up here, I want to do this part first, okay? And I want to make that into an x to the 5th, because that's where you add powers, okay? Everything else just kind of gets copied, you know? And then I think the next thing I want to do is this power to a power thing, and that's where you're going to multiply the powers. And there's more simplifying to do. You should remember from last section that the shortcut here, when you have common bases over top of each other with powers, you're going to what? Subtract the powers for a final answer of x to the 11th. Number 8 looks basically the same thing. So we're going to do this part first, and that's where we're supposed to add the 7 and the 5 together, the powers. Okay? Everything else just kind of gets copied down. You don't want to bite off more than you can chew at once. Next thing you want to do is this power to a power, which means multiply the powers, and then in this situation you want to subtract the top power minus the bottom power. And it looks like the final answer there is x to the 30th. And that's it for section, what was this, 1.7.